Welcome back. This is the third in our series of 3 lessons about the merge sort, and in this lesson we'll finally write the merge sort program. You've already written the function, the merge function that merges 2 lists, and we can use this function to help us create the merge sort. And as I explained last time, the way we do this is to split the big list down into lots of lists of 1 item each, and then merge them all back up again until we get a full list. In previous weeks, I have mentioned that some problems are much easier to solve if we use recursion, and this merge sort is a real life example of that. The recursive version of the merge sort is quite a lot easier to write and neater, but I certainly urge you at the end to have a go at turning it into iteration. So to get ready, open the program that has the merge function in it, or copy the merge function from your previous program into a new Python program. And we're going to use this function inside another procedure. And we're going to write that procedure now, a recursive procedure. So we're going to write the merge sort procedure. It will take our unsorted list as a parameter. I'm going to call it the array. And we're going to split it at the midpoint to make 2 smaller lists. And using recursion, we're going to make this program call itself over and over again. So it's going to keep repeating using recursion until what? What is the base case? When do we stop the splitting? I've already given you all the information you need for that. Now I'm going to go through that program step by step. It would be great if you could keep 1 step ahead of me, but if you do struggle at any point, I'll show you the code all the way through. So let's build up the recursive merge sort using our checklist of recursive functions. So the first thing we're going to do is the header of the function with the parameter. The array is going to be our parameter. That can be any list that in Python list, but I'm just calling it array. Okay, what's the base case? We're going to write the base case next. See if you can do it. And if you just pause the video, write the code, and then press continue, and you'll see if I've done the same as you. So my base case is that the length of the list has got down to 1 only. So once my lists are down to 1 only, that's when I return the list. So if the length of the list is 1, return that list of 1 item. That's when the splitting has to stop. All right, so there aren't many commands inside the function following the base case, but let's just write those. We have to find the midpoint and slice the list into a left and a right section. This is somewhat similar to commands you've used before, so see if you can write that. What we want to end up with is 2 lists sliced at the bigger list sliced at the midpoint into left and right lists. So here it comes. Find the midpoint and create 2 smaller lists. I've called them left and right. You obviously could call them anything you like. The left half of the list and the right half of the list. The midpoint is falling into the right half. And finally, we're going to keep splitting. Now, the recursive part of this function is a little bit different from what you're used to, because there are actually 2 calls to merge sort. That's because we've got to split the left to make smaller and smaller left hand sides, and the right to make smaller and smaller right hand sides. And remember, each version of the function will open its own area of memory, so we'll end up with lots and lots of versions of this function opening in memory, each one with its own smaller and smaller lists inside it. So we won't be able to see this happening inside the memory, but that's what's happening. And then at the end, when we have reached the end of our splitting, we finally return the result of merging the left-hand side with the right-hand side. And once again, this return command will happen over and over again in computer memory as all the small lists get merged together to make larger and larger lists. Okay, so that's quite an unusual kind of recursive function, but it gets the job done in a nice, neat way. Let's look at the whole function. There it is. That's the complete merge sort function. So let me quickly go through it. The base case is when the lists are down to 1 item each. Until then, we carry out the following commands. Find the midpoint and split the list into left and right. We call that split function again and again on both the left and right sides, and the result of that will be to produce loads and loads of copies of this merge sort function in our computer's memory, each one with smaller and smaller lists. And then finally we use our merge function, which we've already written, so we don't have to write that again, to merge all our left lists with our right lists, and that will just keep closing up the lists and merging them back together, and until at the very end it will return the complete sorted list to the main program. So I'll leave that up for a second or two. You can certainly pause the video and just copy that down. So I'll leave you with the following exercises. The first one is to write the merge sort, and I think that one is an essential task to do. Write it by copying the code that I've given you, or write it from memory using your understanding of how it works, and you can test it out on a range of lists. You can feed in any unsorted list, make one and feed it into the merge function as a parameter. You should get it returned as a sorted list. If you're my student, I've given you a big long list of over 1,500 items called town lists, so you can try sorting that. You could try counting how many operations that takes. And my challenge to you is to change the recursive function to an iterative function. It won't change the way the sort works, but it might increase your understanding, and it's good programming practice. And a quite difficult challenge would be to use left-right markers instead of making slices. We'd have to then pass the markers as parameters. So that is a harder challenge, but if you want to get good at programming, the more practice you do, the better. So that's the end of the merge sort. I honestly don't think you can say you've done this until you have written that program. So that is what you must do today. Next lesson, I'm going to introduce a completely new function, completely new kind of sort called the quick sort. All right, see you then. Bye for now.